All right, this will be questions number 1 through 5 on the study guide. So we're just integrating here from 1 to 2 of 1 over x squared dx. So let's say one of the first things we can do is rewrite 1 over x squared as x to the minus 2 dx. In which case we'll just employ the power rule. The answer to this would be x to the negative 1, adding 1 to the power, and then dividing by that new exponent. And that's evaluated from 1 to 2. Doing something similar, writing it as a negative power, we can, if we want to, rewrite this as negative because of the negative 1 over x evaluated from 1 to 2. Okay, so the x to the negative 1 will drop down. Dividing by negative makes it negative. Let's plug in 2. So negative 1 over 2 minus negative 1 over 1. So I get negative 1/2. That becomes plus 1. And we get an answer of 1/2. Number 2, using the substitution, u equals the square root of x. The integral of 1 to 4 of e to the square root of x over the square root of x dx is equal to which of the following? The first thing I think would be beneficial is, and this is something that we've talked about, and I'd suggest memorizing, that the derivative of the square root of x, just real quick, is 1 over 2 times the square root of x. Just real quick, the square root of x is x to the 1/2. And so the derivative of that is going to be 1/2 x to the negative 1/2. So the negative would send it down, the 1/2 being the square root. So it's just one of those things that you take the square root, the derivative of the square root enough, it might be worth memorizing. So when I look over this, if we're doing the u as the square root of x, then that means I need du. So that's going to be 1 over 2 square root of x. We have the square root of x. So what I need to do is I need a factor of 2 in there. Now this is where we need to be careful. We are dividing by 2 in order to get that 2 down here, or multiplying by 1/2 inside. So on the outside, we would have to multiply by 2, not by 1/2. All right, so therefore, now if x is 4 or 1, which are the bounds of my equation, then u is going to be the square root of 4, which is 2, and u would be the square root of 1, which is 1. So putting all of this together, the integral, so 2 times the integral from 1 to 4 of e to the square root of x over 2 radical x dx equals 2 times the integral, changing it to u's now, from 1 to 2 of e to the u. Now again, I can pull this 2 to the square, or 2 times the square root of x off as 1 over 2 square root of x. So that's du. If that's a little tough, just to kind of show you what I'm doing here. Okay, so like I said, the e to the x would be up, and then would be pulling out the 2 radical x off, but it would be in the denominator. And so there's your du. Okay. So we get 2 times the integral from 1 to 2 of e to the du, and that's c. Number 3, so we have to integrate. So in this case here, because we have a composition, I'm going to say let's let u be x plus 1. Therefore, du is going to be 1 dx. So we're all set there. And we'll also adjust our bounds. So I have an x equal to 3 and an x equal to 0. If x is 3, 3 plus 1, u is 4. If x is 0, 0 plus 1 is 1, u equals 1. So this would equal the integral from 1 to 4 of u to the 1/2 du. So that becomes u to the 3/2 divided by 3/2. And dividing by a fraction means multiplying by the reciprocal. Evaluated from 1 to 4. I'm going to come down here underneath, equals 2/3. That means it's going to be 4 to the 3/2 minus 1 to the 3/2. Remember, the square root, the power of 1/2 is the square root of that, and then we're cubing it. So the division by 2, the denominator of 2, implies we're taking the square root of this. So it's the square root of 4, which is 2, cubed, which is 8, minus the square root of 1, which is 1, cubed is 1. 8 minus 3 is 7, times 2/3 is 14/3. All right. Okay, number 4. If f is a linear function and 0 is less than a is less than b, then the integral from a to b of f double prime of x dx equals what? So again, if f is a linear function, then f is of the form mx plus b. 0 less than a less than b means that these bounds are in order, so we're not flipping them and negating anything. So we're trying to find the integral from a to b of f double prime. Well, if f is a linear function, then f prime is just a constant. So f double prime is 0. And what's the area? I mean, if we think about a graph here, the function 0 is just the x-axis. And so the area from A to B is just going to be 0. And then number 5, this is very similar to the one that we did in the study guide. So the integral from 1 to e, we do need to because we don't have a quotient rule. And if we try to do substitution with u being x squared minus 1, we run into the issue of now the du is on the bottom. So we can always split it. So go x squared over x minus 1 over x dx. The first term simplifies to x minus 1 over x dx. The integral of x is x squared over 2 minus the integral of 1 over x is the ln of x. And remember, this should be absolute value. It doesn't really matter because both of our bounds are positive, but it's good to have to get into. So substituting in e, I get e squared over 2 minus the ln of e minus, plugging in 1 squared over 2 minus the ln of 1. So I get e squared over 2 minus the ln of e. These are inverses. They cancel, giving me 1. 1 squared over 2 is 1/2 minus 0. So we get e squared over 2. Negative 1 minus 1/2 is negative 1.5. So I get e squared minus 3 over 2. And that ends question number 5.